Okay, a little do-over here. Solutions test review. Some of this we are not going to have to deal with as far as like what about water, because we'll hit that water unit on Wednesday. All right, so solution is a homogeneous mixture. What is insoluble? Good, does not dissolve. What is a solute? The part that gets dissolved. That's a good way to look at it. It's the smaller word, so it's the smaller amount. So if you have something that's 85% copper and 15% nickel, 85% would be the solvent, and the 15% would be the solute. Molarity. Concentration. Rate. Good. How fast the solute dissolves. Solubility. How much in grams? Wait, what? How'd you say it? How much in grams of solute will dissolve at a specific temperature? Okay. What is the solvent? Great, the part that does the dissolving. And this is the larger word, so it's the larger amount. What is saturated?
Dissolve more solute.
Cannot dissolve more. Excess will do what? Excess will sink. Supersaturated.
Contains more solute than it should.
Contains more solute than it should. What's the key word with supersaturated?
Super. More.
Crystallize.
Oops.
Well, that's why you're doing the dumb candy project. Okay, so you can see the crystals. Unsaturated. Forget it, baby. Unsaturated. More solute can be added.
Whoa.
Shh. Electrolyte. Electrolyte's an ionic compound. Okay, electrolytes. These are the ionic compounds that dissociate in water. In water. They conduct electricity, or they conduct a current. Non-electrolytes are covalent compounds that do not, conduct a current. Now, for my college-bound students, and my students are going on to upper-level chemistry, polar covalent compounds are called weak electrolytes. It's just, right now, we're just keeping it with ionic and covalent. So polar covalent do conduct a small amount of current. So they're called weak electrolytes. Adhesion. Oh, you haven't learned these yet, so we don't have to do that. Why is water a good solvent? Because it's a polar covalent compound. That means it has a slight charge.
Does it dissolve quicker, miss?
Water does the dissolving. It doesn't dissolve. Why bugs land on water? We haven't learned that yet, but that's called the surface tension. We haven't learned this. What type of bonds are between water molecules? What two things can be done to increase the solubility of carbon dioxide in soda water? So we want to increase the solubility. We need to decrease the temperature. And what else?
Add more solvent.
No. What else? Increase the pressure. Great. Awesome. Okay, what are 3 ways in which we can increase the rate at which a solid dissolves? We can stir it, we can crush it, and we could increase the temperature. Why don't oil and water mix? What is that insanity? Why don't they mix? What's the rule? Like dissolves like.
And
They're not alike.
So they don't dissolve.
There you go. Oil is nonpolar and water is polar. The rule is like dissolves like, and they're unalike. Okay, you haven't learned specific heat. What would the following solutions look like if you added more solute to the solution? So what would a saturated solution look like?
Supersaturated.
The solute would sink to the bottom. What would unsaturated look like? Guys, this is the 3rd time we've asked the same question. Look, notes number 2, we said it right here. Unsaturated, the solute would dissolve. This is the 3rd time we've seen this same question. Supersaturated is the excess would crystallize or precipitate out of solution. Exactly. Okay, so calculations. Okay, so how many liters, so we circle liters, this is our liter or our volume, are needed to make a 12 molar solution. There's my molarity with containing 0.75 moles of solute. There's my moles. So my formula is molarity equals moles divided by liters. I'm looking for liters. I put liters by itself. Anything my unknown would multiply with becomes the, so molarity on the bottom, moles on top. Now we're just going to plug and chug. 0.75 moles divided by 12 molar, which is moles divided by liters, so moles would cancel. So 0.75 divided by 12 is what? 0.063 liters, or 63 milliliters. Final answer. What is the molarity of a solution containing 134 grams? So here's my M. This is what grams can become moles, and 650 milliliters. That is my liters. So my formula is molarity equals moles divided by liters. I'm looking for molarity. It's already by itself. So I now need to convert nickel 2 chloride to moles. 134 grams of NiCl2. The words on the top or the words on the bottom. What's the molar mass of nickel 2 chloride? Is it? 129.5 is 1 mole of nickel 2 chloride. So 134 divided by 129.5, and we get 1.03 moles. Now we're going to divide that by the number of liters, which is 0.650 liters. And we get, this has a molarity of 1.59 molar solution. Okay, so let's do the next one. How many moles of calcium nitrate are needed to make a 0.825 liter, or to make 0.825 liters of a 2.65 molar solution? That little area is too small for me to write, so I'm going to write it here. So we have molarity equals moles divided by liters. I'm looking for moles. I put moles by itself. Anything my unknown would multiply with, which is 1 in this case, becomes the denominator. The rest goes on top. So molarity is 2.65 molar times 0.825 liters. And we get 2.19, right? Because of 2.19 molar solution. All right, questions on that? Okay, so the last problem. Calculate the molarity. So here is molarity of a solution at 0.5 liters of a 5 molar standard solution is diluted to a new volume of 0.75 liters. So this would be my M2, my V1, my M1, and my V2. So our formula for dilutions is the initial molarity, whoops, we use 1s and 2s. My initial molarity times my initial volume equals my final molarity times my final volume. So we're looking for So we're looking for our second molarity. We're going to put it by itself. Anything my unknown multiplies with becomes a denominator. Really, Cecil? That's where you are in your life? All right. Okay, so now we're just going to plug it in. The initial molarity, 5.0 molar times 0.75 liters divided by, 0.5 liters divided by 0.75 liters. Do the math. 5 times 0.5 equals divided by 0.75. What'd you come up with, baby? Good. 3.3 repeating molar. That's our final answer. Okay. So now let's go ahead and go over our solubility chart. Substance is the most soluble at 90 degrees. We're going to use our solubility chart or solubility graph. So we look at 90 degrees. This is one of the most missed questions on the quiz. So many students put that this was the answer. No, we're going to go all the way up to the very top, and we're going to come up with sodium nitrate, the tallest one. How many grams of sodium nitrate are dissolved at 10 degrees Celsius? So here's 10. We come all the way up here, go across, and we have 80 grams. At what temperature will 60 grams of sodium chloride dissolve in 100 grams of water? So 60 grams of ammonium chloride here, drop down, and we drop down to 70 degrees Celsius. So 70 degrees. Just reading a graph. Now, what is the saturation level? That's my super unsaturated or saturated. If 60 grams of potassium nitrate are dissolved at 40 degrees Celsius. 40 degrees Celsius, 60 grams. And we're talking about potassium nitrate. So is this on the line, above the line, or below the line? On the line. So it is saturated. How many grams of potassium nitrate can be dissolved in 200 grams of water at 50 degrees? We've got to multiply it times 2. So 50 degrees, KNO3. So that's 80 times 2 is 160. What is the saturation level if 120 grams of sodium nitrate are dissolved in 70 degrees? So 120 grams. So that is below the line, because the line is up here. So that is an unsaturated solution. Okay, on to the solubility, or determining whether things are soluble or not soluble. Okay, so let's look at our table here, our data table. So our first one is lead chlorate. So we're going to always underline our anion and find our anion here. ClO3 is always soluble with no exceptions. That's why I put aqueous. Sulfate. Let's find sulfate. Sulfate is here. It's always soluble unless it's with strontium, barium, lead, or mercury. It's not, so it's aqueous. Again, sulfate underlying the anion